For some examples on using the distance formula, again, I will show both methods. I will use the Pythagorean theorem method, which is a little bit more counting based, and I will also show using the formula, which is a little bit more algebraic. Either one is fine. There's no right or wrong way to do this. Just choose the one that you like the best. And again, remember, I always have my whiteboards with the coordinate plane on them if it's easier for you to use the drawing. Okay, so the question in number 3 is we're trying to figure out if segment AB is congruent to CD. Remember, congruency means have the same measure. So we are going to figure out what the length of AB is and the length of CD and see if they're the same. So using I do need to know those coordinate points. Sometimes it just helps. So I'm going to go ahead and label those. I don't necessarily, because as I work with my AB first, I have that, but so I'm showing you that formula, but I'm not going to do the subtraction. I'm not going to put those coordinates in. Actually, I am. So I'm going to show it completely algebraically. So I'm going to substitute in. Now, which one is x1, y1, and which point is x2, y2 is arbitrary, meaning it doesn't matter as long as you are consistent. I'm going ahead and using the A as my x1, y1, but it doesn't matter. Okay, so you can see that 1 minus the negative 5, and then I have to square that, and then I have 0 minus the negative 8 and squaring that. So I have two values that I can add up. And as I add those values up, I'm going to get the square root of 100. Even though this is a perfect square, I'm not going to take it all the way down to the perfect square, because when we're comparing things to see if they're the same length, this is as far as you need to go, is that square root of 100. So now I'm going to do it visually. Okay, I knew I did one of these visually. So as I start work with D and C, again, I have to work within the coordinate grid. So I'm having to make that perfect right angle using the lines of my coordinate grid. And so now I simply need to count. So as I count across on my D, I have gone 9. And to go up and down, I have gone up and down 6. That's just counting. And so then to find the length of CD, I'm going to be able to use my Pythagorean theorem. So I will just substitute in the 9 squared and the 6 squared. Keep in mind, these are those perpendicular distances, the true horizontal and the true vertical. The diagonal piece is the one I don't know. So that's my C squared. And so again, I'm going to finish that up. So now my C squared, turns out, is 117. So now I need to square root. C is actually my distance of CD. So it is the square root of 117. Now, like I said, we don't have to figure out what that number is. I can see that AB was the square root of 100. CD is the square root of 117. Those are not equal. Therefore, segment AB is not congruent to CD, segment CD. Okay. So with 4, when I don't have the graph, I do tend not to, but I would like you to try if you want to kind of sketch out. I'm not going to show all of this work. You can choose either to use the formula, or you can choose the Pythagorean theorem. Either way is fine. Go ahead and pause the video to give yourself time to work. And when you come back, I will be showing you the answer. So the length of EF is the square root of 13. Again, just keep it in that square root form. Don't worry about simplifying right now. If you're working within the textbook, I think they will always tell you to round to the nearest tenth, in which case just grab your calculator and you may do so.